Hello everyone, today in this video we're going to attack this web application, gain remote code execution, and then catch attackers in the middle of their game by developing some detections. Let's get started. We're going to be using DevBox, who are sponsoring this video. They gave me access so that I can showcase to you guys what this platform is capable of. And I just loved the platform. Let's log into our account and we're going to tackle the notes service. So let's view this challenge and start the lab. Up on the lifecycle area, we have big phases right here. So the first one is deploy. The VMs are currently being deployed. And if we scroll down here, we should have the IP address of our target shortly. So if you go back to the labs while it's deploying, you can see that there are other menus like the scoreboard, which allows you to see yourself among other peers based on the points and achievements. Down here, you have your profile, and then you can purchase plans here. Because DevBox are sponsoring this video, when you use the code HACKERISH, you get 50% discount on your first month. So don't forget to use HACKERISH. So the lab has been deployed, and as you can see, we have a count down here, about an hour to finish our challenge. And the IP address is right here. Let's copy it and start exploring this application. So I'm proxying everything through burp, and right here we see our requests. So let's start exploring this application. We can create a note, and we can find a note by its name, provided that we have the encryption key. All right, let's create a note, a HACKERISH. This is a very secret message. Don't forget to like and subscribe. Let's give it an encryption key of DevBox and then create. All right, note created successfully. Let's go back. Let's try to find this note. The name is the HACKERISH. Encryption key DevBox. Well, I made a typo here, but let's try to find it. And we're given back a gibberish message. And it says here, if the key is not valid, you'll get an encrypted version of a note. Okay, let's use now the correct encryption key and find it. And sure enough, we have our message back. Let's see if we can find anything interesting other than those two endpoints. Well, first of all, to guide you through the lab, DevBox provides what we call highlights. These are flags that you can collect along the way. So the first thing is, what's the weblog path? You can see that I've already sent a value because I'm tinkering with this challenge before. But if we scroll down here and expand the URL section, we have the question, what is the endpoint that is being used to create notes? And what is the endpoint that is being used to get notes? Post/note gives us the message, the note, and then post/create creates the message. We're going to leverage burpsuit's scanner because this is one of the ways that we can fuzz our endpoints and try to find any interesting vulnerabilities. Let's target note request. I'm going to send it to the intruder, and I'm going to select only the two parameters. This is where I suspect the vulnerability will be. Right click, scan defined insertion points, and open the scan launcher. This is where I'm going to configure my scan. I don't want to run everything. So I want to go to issues reported, select everything and disable it, and only select OS command injection. Save, okay, and now it's running right here in the dashboard. Why I've chosen OS command injection? It's because if we go back to DevBox and if we go to labs, you see that the notes service is a Flask application. One of its endpoints can be an entry point for an RCE. If we go to logger, the scanner is actually doing a bunch of requests that contain different payloads. So here you can see it's trying to use ping command with some pipes to inject some code. And sure enough, you see that the target has been highlighted in red. If you go to dashboard, we have indeed a vulnerability. Expand a little bit. We have an explanation, and the first request is running ElasticSearch with something that points to a collaborator instance. The collaborator received a DNS lookup. The second request is echoing a gibberish message of 2 words, and sure enough, we get the words back. Let's take the second one, send it to the repeater in order to try to understand it and play with it. So first of all, I'm just going to decode the encoded payload, and as you can see here, we have the hackerish, the name of the node, and then we have a pipe, which is a classic operating system command injection technique, and then we echo those 2 strings. But since these strings are identical, we don't know which one of these parts have been executed. So what we can do is remove them one by one and see where did it work. Okay, the payload is being simplified. So our payload terminates the string, then pipes it to echo, and then terminating with the hash symbol to comment out the rest. So I think we can safely remove this part right here. Let's cross our fingers, encode everything and send. Oh, did not work. Okay, let's maybe add a space. And now it's working. The interpreter ends up evaluating the first part of the command and then launching the second one, which just returns our message here. How can we go about detecting this attack? If we go back to DevBox, we have Kibana. We will use it to authenticate using the username and the password provided. And we land on the Kibana dashboard. If we go to Discover under Analytics, we can see a bunch of events from the audit beat index. So let's send this very request and then refresh. So it's a little bit tedious to actually go one by one and look for our interesting events. So what I can do here is look for process.title, which gives us the command being run. And here we have SSH. Let's go ahead and send a bunch of these requests just to generate some traffic. All right, we have apt check. We have, cat notes / the hackerish, a bunch of payloads that are similar to our injected code, bin sh-c, and then our command cat notes / the hackerish. So it seems that our note is being stored under the notes directory, and then we echo this payload right here. So basically, a benign notes name should potentially not contain double quotes, because if it does, then we will break out of the context of this command and then start another command. I'm going to filter on the process title field, and this is Kibana query language. We want something that contains cat, then notes / then something. So as you can see, we have all the payloads that have been generated, including the benign ones, which just included the hackerish note. So we need to make it a little bit more specific. As we discussed, we need something indicating the end of our command, which is double quotes. So now we have 2 hits in the last hour, which is not what we really expect. The original command was cat and then double quote. So we need to add this right here. And now we see more. All right, so let's test it out. Try something like wget https hackerish.com and send it, refresh, and indeed we see exactly the payload that we've sent. So if we click on attack, we have 3 scenarios. reverse shell and denial of service, a hidden reverse shell and HTTP deface. Level 3 is HTTP C2 and service deface. Honestly, all of these can be detected using our generic yet somewhat specific query, because if we wanted to target the reverse shell part, we need to, for example, look for the different ways a reverse shell could be executed. So here we have the pentester monkey's reference to some reverse shells using different languages: Bash, Perl, Python, PHP, Ruby, etc. And for each one of these, there could be hundreds of variations. So it's better to just make it generic like this. So under security, go to manage. We're going to create a rule, and let's use the threshold because we want to measure the number of occurrences of any match. We don't want any of these indices. The audit beat is enough for us. And here we can input our query. Perfect. We want the threshold to be 1 because as soon as someone tries any malicious payload, we want to get notified. Then we continue. We can give it a score of critical because someone is tinkering with our website. And let's give it a name, RCE, and then description, the notes, app while the dev team is working on a patch. Continue. We want to run it, let's say every minute. And then as soon as this rule matches, we want to send a request to a webhook. So I'm going to create a connector. Let's call it webhook, and it's going to be a post request, and the URL will be this one right here. Paste it right here. It does not require really any authentication, so let's save that. And for the body, let's just send an empty body. Doesn't really matter here. Let's create and enable the rule. All right, our rule is up and running, and we just need to trigger it. Let's send yet another request. And here's the last one that we've just sent 21 seconds ago. So the next step is to go and test our detection by clicking on attack, and let's jump straight to level 3. So the lifecycle now jumped to hack. The attack is happening right now, and you can see it in the timeline section. So if I scroll down, here it is, multiply or multiple. So let's see, show more. You detected an attack at that moment. The web listener has been set up to send the commands of the C2. Initial access has been done. Sending the web shell payload, and then pwn has been successful. And we detect that attack at the moment. Now, if we refresh, we should see more alerts. And yes, indeed, we have 4 alerts now. And this one is the malicious one. So if we click on investigate in the timeline, here is the entire payload. As you can see, it's a typical reverse shell using Python, and we've successfully detected it. And we have achieved some badges, including what seems to be a false alarm. I think it's because there are some requests that did not trigger code execution. The most important thing is that we've been able to detect this attack right when it was executing. And I mean, it's really cool to have a platform that allows you to both do attack and detection. Playing the red and the blue hats is really crucial in bridging this gap between attackers and defenders, and it certainly allowed me to discover the blue part, at least from detection engineering. So I hope that this video was useful to you. Don't hesitate to go to DevBox. As always, stay curious, keep learning, and go find some bugs.